D8 utility, JSON. Performance Showcase. What to look for. Template-based segments instead of pointers for optimal cache utilization. Index and reference instead of copy and duplicate memory. Delayed computation. Work is not performed until needed. This prevents doing work that is not useful or never utilized. Modern C++, open source, cross-platform, high performance, benchmarks, and unit tests. Here is how segments increase performance by reducing cache load. This is how most JSON libraries are implemented. Starting with a JSON buffer, it's parsed and converted into a map, with each key-value pair being represented by a node in the map. The key is copied to the heap. The value is a union, which can represent any value type, including a pointer to a map that's another object. These libraries are essentially implementing JSON as a language feature, instead of a data format that we decode into our language constructs. I'm not the biggest fan of this approach, as in my experience it quickly devolves into programming in JSON. The D8 utility library implements a minimal cost abstraction on top of the JSON buffer, using segments and pointing into the buffer itself. Usually I'll use this to memory map a configuration file. Decodes happen on request and are not pre-processed. This is designed to fit the paradigm that we shouldn't program in JSON. We should convert that data as quickly as possible into our classes and our structures, and use the programming language as intended. Let's take a minute to look at the result of all of these innovations and optimizations. With a medium-sized JSON buffer, the fastest algorithm of all of them is the 16-bit segment algorithm. The 32-bit and 64-bit segment algorithms are about twice as slow. Adjusting our paradigm about how JSON should be parsed and utilized provides a 10 times performance difference between the 16-bit segment method and the closest open source that we tested. These numbers remain relatively unchanged as we go from a medium-sized buffer to a large-sized buffer. With this larger buffer, the closest third-party function that we tested is still over 7 times slower. This shows the value of what I like to call lateral thinking around our assumptions. If we make the assumption that our JSON library has to be like all the others, we'll have lost all opportunities to innovate. All that being said, parsing JSON 7 times faster really doesn't matter, it's just JSON. The power comes from our ability to use these same principles in solving any problem. Thanks for watching.